So what's the solution, right? Well, the old solution, right, is to have something called a repository, right? This idea, it's like basically it's this pot or this sandbox where everyone puts all the files, right? And whenever they want to do something with them, they take the file out, they do something with it, and they put it back in, right? And so you can think of it as like a database or a file system or whatnot. But the point is, in the old version, this is centralized. So it was a client-server model, right? And basically, if I wanted to edit file 1, 2, or 3, I would take it, change it, and put it back in. And the really cool thing about these systems is that they had a history. And all version control, revision control systems have a history, because that's kind of like that's what we want. Here's a very simple example. Today, Bob changed this. Yesterday, Bill changed that. And you can see who did what, right? But there's a few problems with these systems. Since everything is centralized, right, and you need to control how data goes in and out. You need to have mechanisms to make sure there aren't conflicts. After all, you're trying to resolve, the very thing that you had a problem with. So there are a couple different methods, but they have their disadvantages. A lot of the older systems, in fact, I don't even know if any of the modern systems use this. They use a lock, modify, unlock. So the idea is that if you had a file, like this guy right here, right? If I forgot if this is Bill or Bob, but this cat, right? If he decides he wants to edit this file, he will go ahead and tell this central repository that I'm taking file ABC, and this repository will lock it. So it would make it so that anybody else cannot access that file or edit it, right? Well, it turns out, even though that works, right, is that it prevents people from working. He decides to take a coffee break. He forgot to check it back in, before he left for the weekend. And next thing you know, this other dude can't edit baloney, right, because he never put the file back in, right? And similarly, you have a problem with a somewhat better, but still lacking mechanism in copy, modify, merge systems. So in this case, it's slightly different. Again, it's all centralized. The best example is that we can both check out the data. We can both read file ABC. So this guy reads file ABC. This guy reads file ABC. And they start hacking, right? And actually, what happens with copy, modify, merge is it's a race. It's who can commit the file the fastest, right? Because if I can commit it before you do, my changes are going to go in, and I don't have to worry about consolidating any differences. So in the case of the guy on the left, he went ahead and committed his stuff at midnight. He put it back in. And so when this guy tried to commit his version of the file, a minute later, the system blocks him and says you can't because you actually don't have the latest version of this file. So then what this guy's forced to do is have a copy of his file, right? Take the updated copy from here, and then what he has to do is basically fix everything on his own. So he has to merge left guy's changes with his own. And so he has to deal again with this headache of putting everything together, right? And only then, once that's done, can he put it back in, right? Another problem with these systems is, well, you need to be able to connect to them. It's a client-server model, so if you're out and about, like an airplane, that's a bad, airplanes have Wi-Fi now. But the idea is that you need to be connected to the central repository. You always have to have a connection. Basically, if you don't have a connection, you can't get the code, right? You may have a copy on your own, but it's stale. You never receive other people's their updates, right? And so the next time you actually synchronize with this repository, you may find out all the changes that you have made, won't commit because you were using old versions of that file, right? And the guy, who's on the ground can happily keep doing things, and obviously this guy is not very happy, right? There's some other problems with the centralized systems. I won't get too in depth with them, because it assumes that you actually are very familiar with them. You're familiar with things like CVS, with Subversion. How many of you guys have actually used Subversion for CVS here? All right. So in which case, you know a little bit about branching and merging and how that's not a pretty operation at all. Maybe at the end of this talk, if you guys have questions on why that is, I can elaborate. But there's no point in doing so now if you're not familiar with these systems. And performance isn't very good. Mainly because these systems or this particular flavors of centralized, the most popular versions like Subversion, they keep track of files. So they keep track of changes in files. So you delete a file, all that history is gone. There are actually better ways of actually keeping track of changes in data in the repository. So what is the solution? Well, you take out the centralized concept. What if everybody had a copy of the repository? Well, then that means you can do whatever you want, right? This guy can change and do all his business because he's not going to conflict with anybody else, right? And same thing with that dude, right? They can add and subtract and change as much as they want, because they each have their own repo. So it's almost like they have their own client server and they're the only person actually working with them, right? And what's interesting with that is that whenever there's a third party that actually wants to get a copy of this data, what he does is just clone the repository. So in this case, this guy has a repo with some code, for some project, right? And this guy wants to go ahead and actually look at the project and start fooling around with it. What he'll do is he'll just copy the whole repo, and he'll have his own copy, right? And so that's what we mean by a distributed revision control system. The idea is that basically everyone has their own repository, right? And if people actually want to share data, they can either pull or they can push the data to other people's repository, right? So now you have a network of servers that actually live on the client. And that's a really cool thing about the distributed systems like Git or Mercurial, is that you don't have to set up a server. It's just a program that lives on your computer. And so, like I was explaining before, if oh, that's right, this is Bob. If Bob went ahead and had a copy of this repository, right, and he made changes to file ABC, and obviously the repository keeps track of all these changes. He fixed some bug. Today, 3 days ago, he added some method, right? What happens is that this guy on the left, which is Bill, now that I remember, right? Maybe he wants his changes. It's like, hey, I like your code, let me take it from you. So what he actually does, he actually pulls that information to his own repository. So he just copies that, that set of changes over, right? And the cool thing is that all the information about the changes and who made those changes is retained. So when he copies that over to his own repo, he knows that these changes came from Bob, right? And these changes occurred at this time, right? And the neat thing about that is that he controls how Bob's changes are merged into his repo, right? Since it's his repo, he can control what actually ends up happening in the end. And likewise, because Bob has his own repo, the fact that he's sending his information over doesn't affect him at all. He's just sharing data, right? And so the other side of that is push, where you can actually push data to somebody else, right? And again, everyone has a copy of the full repository, right? And there's no harm done. What gets interesting is when you start having multiple people and they're all talking to one another in different forms of collaboration. Now, this is very interesting with like the Linux project. The Linux kernel actually works this way. the Linux kernel has used two different types of distributed revision control. GIT, which Linus Torvald himself actually built. And before that, they used a system called BitKeeper, which was a commercial system. And the idea is basically that Linus Torvald goes ahead and pulls from certain people, right? When you're talking about a project that big, right, you're not going to pull from everybody, right? Because there's hundreds of people who actually work on the kernel, right? He actually only pulls from his lieutenants, right? So he has one lieutenant that all he does is the networking stack, right? And so he pulls networking stack stuff from there. And you got the other guy, who does I/O things, right? And then he pulls from the guy who does I/O, right? And so, maybe hypothetically, if this was Linus, right? Maybe this would be network stack guy and this would be I/O guy, right? But the really cool thing is that network stack guy can pull from his 3 soldiers, right? They basically do his dirty work, right? And so what happens is you actually develop a network of trust where, lieutenant pulls from people he trusts, right? He merges all that code, right, for, the networking stack, right? And then the general goes ahead and pulls from his lieutenant to get all the information from that piece of, the project that he wants, right? And so, depending on your organization, right, and how the system is split up, and the senior and junior developers and whatnot, you can come up with a whole array of different ways to pull and push in different layers of using a distributed system, right? And so in that way, you don't get the newbies, clobbering your code, right? Because that can very well happen in a centralized system, right? All it takes in a centralized system, because that's the cool thing. If we kind of go back, what is this? That's up and down.
You went forward, I think.
There you go. If you go back to the centralized system, right? Which one do I go? Who's to say that this guy actually committed something that was good? It could have been garbage, right? And so when all the other developers go ahead and get the latest, version of the code, he just broke the whole project. It doesn't compile, right? Because he was just allowed to commit something because he has commit access. And actually, that's a phenomenon that happens in these centralized systems, and especially in open source projects that still use centralized version control. Is that who do we give commit access to? That's like the holy grail there. It's like if you have commit access, that means you have power, because you have the ability to affect everybody. But guess what? When you have a decentralized thing, we don't care, because it's the other person who's determining whether or not you're affecting his own repo. And so now I actually get to throw out some names. This whole time I actually even haven't done that. There are 2 really big open source distributed revision control systems. One of them is Git, that was developed by Linus Torvalds. It's the same guy who developed the Linux kernel. The other is called Mercurial, and now I feel bad that I don't remember the guy's name. Git, I would definitely say, is the most popular. It's used by a lot of people, and when I show you GitHub, I will show you some of those projects. Mercurial is still very popular. The Mozilla Foundation uses Mercurial. Oh my goodness. I know the Python developers are in the process of moving towards Mercurial. Bits and pieces are sub-projects within Python are using Mercurial. The Zen project, Open Solaris, a lot of what used to be Sun, rest in peace. I know it was using Mercurial. And there was one other big one that it's at the tip of my tongue, but it's not coming out. And so at this point, I would like to direct you to the internet. And so, oh my goodness, this is bad.
Did we get our connection up?
I'm tethering.
Okay.